Discord kind of question community review events. We are doing domains. What is today? Domain 4 and 5, actually, of the KCNA exam. So we're actually going to review some KCNA questions. A lot of this is actually, or some of this actually, is on the CKA, CCAT exams. Uh, so here we go. Yeah. All right. So, sounds like at this point, everybody can hear me. Any updates about the recordings? Yes, actually, someone was asking. I actually have a playlist link to share with you so that you can have access to the previous recordings. And behold, today I have a special gift for each of you, which is that I actually have a PDF file that not only has all of the questions in it for a review, which I will post here after we're done, but I know, shocker, I know like some of you are going to be like, what? Michael, you're going to be like, the answer, by the way, is not always B. So, I finally was able to do a little bit of machine learning, maybe even a little bit of generative AI, and was able to somehow figure out the distribution weight. Yeah, I know, it's sad. It's sad that it takes an engineer that long to get that corrected, but it may have been an attention problem, a focus problem, and not a technical problem. But, I don't want to out myself. Okay. We're going to try something new today. So, because that's the fringe. Let's try something experimental. So I'm going to share my screen, and we are going to actually use a completely made up, first time use uh, interactive quiz app. So, yeah, you're like, oh, this is going to be dangerous. Yeah, it is going to be dangerous. Let's get it. All right, let's share this first. I'm going to share my screen. I'm looking off to the side just for a second because I want to be able to see all. What I'm streaming. Yes, I'm streaming this. Okay, I'm assuming because it's showing a screen, it's basically showing me that you guys can see my screen. Yes? Yeah. Yeah. Okay, good. All right. So we're going to try this. I actually do have the document in case this is a horrible failure, but this is what we're going to be using today. Let me blow this up actually because maybe that would be more readable for y'all. Yeah, there we go. Okay. By the way, I missed my exam Saturday trying to reschedule, but no luck yet. Oh, sorry to hear that. I actually, for those of you who aren't aware, the CNCF just released a new Cloud Native Platform Engineering Associates exam. I actually just took it. I got cut off in the middle of it, which was first time that's ever happened. So anyway, yeah, I lost some time there. But regardless, we'll stay focused on KCNA today. Oh, don't forget, by the way, yes, I did finish it actually. By the way, they tell you this at the beginning, but of course, like a good engineer, I didn't read the directions. When you get cut off in the middle of an exam, you just rejoin like normal. They walk you back through the entire process. So it's really maddening because you feel like you're going to lose time. And then when you get reconnected back in, they just dump you right at the last question that you were looking at. So, yeah, there's that. Okay, I'll talk more about that. All right, so let's talk about the three pillars of observability. Um, so if you get cut off, by the way, you just go back in like normal, and they hook you right back in. So domains 4 and 5, by the way, are about cloud native observability and application delivery. So KCNA exam, by the way, is a broad overview of what happens in the industry. So what are the three pillars of observability? So remember, observability is the new monitoring, right? So then what have we added to monitoring, right? Which used to include, I'm just going to give you a hint, metrics and logs. What have we added to make it observability, right? And I say that it's not just that we added, traces, right? So I kind of gave the answer away. And some of you answered C, right? But we've added basically more awareness around the significance of monitoring and observability, basically. So, all right. So the correct answer is C. Notice, by the way, it's not B. Woo! Celebrate. I know. You're like, what? For those of you who weren't here before, by the way, we kept running into it where the answer was just B. It was just B. And so even if you didn't know the answer, after a while, it was just B. So the three pillars of observability are metrics, logs, and traces. You could probably add other pieces in there like dashboarding and events, but really these are the three core pillars. So, there you are. So Obviously, if observability could include metrics about usage, consumption, and disk storage, it could involve promotion through environments like test, development, and production. Not really, actually. That's probably more like continuous promotion and CI/CD. And then application services and databases and distributed architecture, that's a pillar of something. I'm not sure what, but it's definitely not observability. So answer C. I know, it's getting better, right? I'm improving. Progress, not perfection, right? Progress, not perfection. That's what's happening. Let's see. Jiganesh, you were asking about the compiled PDF they were talking about. It'll be pasted here at the end. I actually will paste the compiled PDF into the KCNA channel after we're done. So you'll see it there. All right. Next question. What type of data does Prometheus primarily collect and store? I mean, it's kind of a gimme, right? If you've kind of aware of the landscape, but if you've never touched the landscape, this question could be pretty hard, actually. So what type of data does Prometheus primarily collect and store? Container image data, time series metrics data, application logs. That'd be nice. User authentication credentials and authorization policy configurations. So if you've ever even touched Prometheus or read in the docs, right? I see some of you have placed the answer here. The answer is definitely B. Prometheus is all about storing time series metrics data with labels for basically monitoring and reporting purposes. It also has other pieces, but we're going to leave it there. So these are the kind of questions you're going to see on the KCNA. All right, moving on to the next one. What is telemetry in the context of cloud-native applications? Security protocols for encrypting data transmissions between services. Sounds like something different. Version control systems for managing application source code repositories. I'd say definitely that's not it. Deployment automation tools for releasing applications to production environments. No, definitely not. So even by virtue of elimination, we probably would land on automated collection of data about applications and system behavior. Yeah, I see a bunch of D's there. Good. Thank you for participating. So it's really going to be D, telemetry, right? Telemetry is basically information about the state or state changes inside of a system, really. Doesn't matter if it's a operating system or a container system or an orchestration system or an application system. They're all tiny little systems, so you're just automating a collection of data. That's all. So definitely not security protocols or version control systems or deployment automation. So I will say that people have asked, hey, is it really this complicated or this easy? Or sorry, is it really this easy on the KCNA? A lot of the questions are kind of like this. They're really just testing whether or not you have broad knowledge of what these things are, how they're defined. Full disclosure, I got an 85 on the KCNA exam. I'm kind of proud of that because I actually didn't study for it. I got a 96 on the CNPA exam, the Cloud Native Platform Engineering one. That feels like kind of a fluke, honestly. Not that the score matters. If you pass, you pass. It's very binary. All right, so what is distributed tracing used for? This is a good one. Are you tracking requests as they flow through multiple services? Are you encrypting communication channels between microservices for security? Are you storing application configuration data, or are you managing user permissions and access control policies? Now remember, tracing is one of the three pillars, right? So you've got metrics, you've got logs, you've got tracing. You could throw dashboards and event tracking in there, state tracking, but really those are the three pillars. So what is distributed tracing for? What would you be tracing in a distributed fashion? It's definitely not encryption, right? Because we actually saw that before. Storing application configuration data, app config is cool, but probably not what distributed tracing is for. Managing user permissions is definitely not a security function. So I see a bunch of you put A. Let's see if that's the right answer. And it is indeed A. So, I mean, by the way, can someone name any distributed tracing like framework or system? Any like tool that you would use for tracing? Could be open source, could be third party. Jaeger. That's right. Jaeger. What does that mean? Doesn't that mean like hunter in like German or something? Anyway, yes, Jaeger is definitely one. Name another one. New Relic. Yes, New Relic definitely has tracing, especially with their APM tool, right? Their application performance monitoring tool. Datadog. Oh, Cat, I'm not familiar with Jägermeister or Jaeger Mister. Oh, yes, the alcohol. Yep, that's. I am unfortunately familiar with that, but not from a consumption standpoint. I used to be a bartender back when I was in college. Um, Jaeger, New Relic, Datadog, Zipkin is another one that shows up on occasion. What's another one I've seen? Pixie shows up. I used to say OpenTrace, which is a CNCF project, but I found out they archived it because nobody was contributing to it. Jaeger was the winner. All right. So if you hear the words Jaeger or Zipkin or Datadog APM or New Relic APM, they are typically talking about application performance monitoring. They're typically talking about tracing. All right. Let's talk about the primary purpose of setting up alerts in a monitoring system. You're probably, wow, Michael, really? I mean, this is the old school sysadmin stuff, right? It's like, what do we set up alerts for? What do we need to be alerted for? Exactly. Do we want to generate detailed application logs for debugging purposes? No, but that's nice. I like that. Do you store historical performance data for compliance reporting? I mean, yes, unfortunately, that does happen. Automatically deploying new application versions when they occur. Ooh, man, that's like continuous deployment right there. Notifying operators when systems metrics exceed defined thresholds. Okay, so I see a bunch of you put D. How many of you, by the way, when you saw the word operators, instantly thought about Kubernetes operators? Was it just me? It was just me. For a moment there, I was like, operators? Oh, wait, are we letting like custom resource definitions know when system metrics? I was like, oh wait, operators? You mean sysadmins and DevOps people? Yeah, operators like the people, exactly. People who are operating. So, answer here is D. Notifying operators when system metrics exceed defined thresholds. Or, yeah, depending on which direction the threshold is in. But that's the idea. So, for example, if CPU exceeds 80% consumption, error rates like 500s, spike above normal levels, that kind of thing. So it's definitely not the rest. Excellent. Okay, let's take a look at the next one. What is a service level objective? Is it a target value or range for service levels measured by SLIs? Is it a legal contract between service providers and external customers? Wow, that sounds rough. I've been in the middle of those. Is it a method for deploying services to production environments safely? Or is it a configuration system for storing service deployment parameters? Now, SLOs, SLIs are basically all about, you know, indicators and thresholds for those indicators. A service level agreement, an SLA, is typically a signed contract between people about what these SLOs and SLIs will be and what will be the remuneration or the payment if you violate that SLA, right? So an SLA would typically be B. It would be typically a binding financial legal contract between a service provider and external customers. So in this particular case, there's a range of answers. A service level objective is basically a targeted value that says our objective here is that we need to maintain CPU utilization below 80% or between 60 and 80, right? Because we want to maximize usability. The SLO is usually indicated by an SLI. That's a service level indicator. It says this is where the service is at, right? Are we within the range or are we not within the range, right? That's what we're looking for. And an SLA, of course, is that legal contract between service providers. So, yeah. Yeah, they kind of go together. By the way, Does anyone know the name of the role that typically has to like honor, adhere, and pay attention to SL whatever, SLIs and Os deeply? Yeah, oddly enough, it has S in the name. Yeah, Kat, I see you got it. Yeah, SREs, right? So if you've ever, ever looked at the Google SRE handbook, right, it talks a lot about it, right? Yeah, there's usually consequences for not staying on track. So for example, right, measured by an SLI, so basically what I said before, here's an example of a threshold. Yeah. So obviously, I think we already talked about this. This describes an SLA. This is all about CI/CD pipelines, and configuration storage would be like config maps, of course. Yeah. Okay. Which tool is commonly used to visualize Prometheus metrics? So what is used in conjunction with Prometheus metrics? Docker Container Platform, Grafana, Dashboard and Visualization Platform, kubectl command line tool for managing Kubernetes, and a Git version control system. I feel like this one, if you've ever worked with Prometheus, yeah, you're all on it. It's Grafana. Okay, so what's an alternate that you could use for instead of Grafana that probably isn't as slick or as easy to use, but people sometimes still use it? What's an alternate to Grafana? What about Kibana? Uh-oh. Yeah, Kibana maybe. Maybe. Although the integration there is not super tight. Prometheus does have a dashboard built in. I would say it's probably not as slick or as easy to use as Grafana is, especially since you can just download templates with Grafana. OpenTelemetry could definitely be a part of this, but that acts more like a storage collector. Oh, you could definitely dump metrics out of Prometheus into Datadog. There's also AppDynamics. You can also dump out into New Relic. What else have I seen? Dynatrace is another one I've seen, right? Um, Oddly enough, I'm just going to share this with you. I just found out, this blew my mind. There's an open source dashboard called Perseus. Perseus? Perseus? That's a CNCF dashboard. It's called Perseus. Perses. Perseus. And it's out there, and it also does dashboarding. Yeah, Perseus. I think that's right, Kat. It's like Perseus or Persis. And apparently there's only a few people working on it. So, but the CNCF does have its own dashboarding tool. But I mean, honestly, Grafana is amazing. So anyway, answer is B. Obviously, Grafana. You know the rest are not. Docker, kubectl, and Git. That's not a thing actually for this. All right. What's the purpose of resource quotas in Kubernetes? And Kat, by the way, I think it's that second one, that Persis, Perses. Yeah, I thought so too. Okay, so resource quotas are, optimizing resource allocation algorithms, provide network connectivity and routing between pods and services. Do we limit computing resources that can be consumed basically by workloads and namespaces? Or is resource quotas used for encrypting data at rest and in transit for security? Now, there are a lot of Kubernetes specific questions about Kubernetes management and objects in the KCNA exam. And so, if you've taken the CKA before, you're kind of like, that's pretty straightforward, right? I think the other thing I've seen them ask about is limit ranges, which, yeah. Anyway, bottom line here is that the answer is indeed C, is that resource quotas are used to basically add quotas or limits to resources. That's what it's there for. Good. You're all on top of it. Yeah, I don't know that I want to mention anything else there. All right, what can cause unexpected cloud costs in Kubernetes environments? Oh my gosh, this question feels like a trap. Let's see. Using too many labels and annotations on cluster resources? No, that's pretty much free. Creating excessive numbers of namespaces for organizing applications? That's pretty much free too. Over-provision pods in unused persistent volumes, consuming resources. I mean, yeah, I think that's true. Cloud costs, absolutely. And then executing kubectl commands frequently during development operations. I don't think you get charged per API call per se. So there's two things that we joke about that are hard in cloud, that it's different from what's hard in Kubernetes environments. I know this is going to sound weird, right? That's true, Kat. Good point. D could be used if you're just listing things. That's not a problem. So there's two things that are hard in cloud, and that is billing and security, right? That typically they joke that like billing and security are hard in cloud because billing is often weird and unexpected, and there's data transfer charges, and when do those data transfer charges show up? And when you start a load balancer, you got to pay for it to be up a little bit, but also the amount of data that's run through it and the things that you enable, and it gets all really strange and weird. So billing is typically hard in cloud costs, and then the second thing is security can be difficult because there's just so much there. In Kubernetes, it's typically networking and security. So they both share security, but with Kubernetes, networking is considered to be really difficult, and cloud billing is considered to be really weird. And so in this particular case, if you are over provisioning pods, which means you're using more than you need, and you have unused persistent volumes, which means you are, let's say it's AWS, and you're using EBS, right, or EFS as the underlying persistent volume host, you're paying for stuff that you're not using, right? Now, I will tell you that storage is typically relatively cheap, but let's say that you get a really fast, lightning fast hard drive and you don't use it. That could get expensive really fast. So the answer here is C. Basically, if you over provision anything in any environment or you start resources that you don't use, that's going to cost you. I one time started a SageMaker endpoint and cost myself $3,000 in charges in 24 hours. I started a huge SageMaker endpoint and then forgot to turn it off in AWS. Yeah, that was fun. By the way, AWS was so nice about it. They were like, yeah, we'll roll it back. And I was like, cool. They were like, don't ever do that again. And I was like, never. And yeah, exactly like you. I was like, never again. I will never start anything of that size again without it being in my business account. Yeah. So the only thing, Kat, about dynamic volumes is that, yes, if it's dynamic volumes, I think that would be better because then they start and end with the life cycle of the workload. Some people are still using static definition of volumes, basically persistent volumes. Yeah. All right, so for what caused unexpected cloud costs? It's over-provisioned, basically usage. Okay. What's the primary benefit of using resource requests and resource limits in Kubernetes? So very similar to what we were doing before. Are resource requests and limits about encryption? Are they about storing app config data? Or are they about providing network routing and load balancing? Or are they about ensuring basically predictable resource allocation, but mainly to prevent resource contention? I used to have a practice that when I started clusters, I would actually have a bad actor node that would start up. I'll answer that in a question, Kat. I'll answer that question in a second. So I would have a bad actor node in the cluster, and if one of the systems started running against the resource quotas or limits, especially if it was a new application, I would pull it over into the bad actor node, give it unlimited access to like a 32-core, 128 gigabyte node, just to see how much the pod would consume, so that I could then tell the development team, it was like, hey, your stuff, since you made this last application change, it now has gone from like an 8 gig limit with, let's say 2 CPUs, and now it's using 4 CPUs and, 16 gigs of RAM. So I usually will have a bad actor node in the cluster that I can basically just pop it out into, because we don't often do performance profiling before we launch an application, especially when we do application changes. And so sometimes it's good to have this node that has unfettered resource requests and limits, and the only real limit is the size of the node in question, just to see how the application goes, especially if the application keeps choking off of the resource requests and limits. Sometimes that's good. So as I probably just indicated from that, it's basically to prevent resource contention. Now, why I would never run a production cluster without resource requests and limits, and the reason is because if you have a bunch of different workloads on a cluster, you've got to prevent and you got to put guardrails around the applications, because otherwise they'll use all the resources in the cluster, and that can affect the other applications. And so you do that so that people play, like, applications play nice with each other. And so that prevents like an application going rogue and taking all of the resources on a node, which can cause problems, especially if all the nodes are struggling for resources. So, yeah. In the case of the bad actor node that I was just talking about, where we had a bad, a bad actor, it's like an application that kind of went wild. That node actually started on the fly when we allocated it, and it actually just got allocated at the time that it was needed. So that virtual machine wasn't just sitting there waiting for workloads. It started at the time that it was needed. So, or sometimes we would start it and move things there on purpose. So, but the main idea here is that resource requests and limits are all about just either preventing basically applications from stealing resources from each other, and so you want a predictable set of resource allocation. Can that get inefficient? Of course, because people are like, I need 8 gigs of RAM and 5 CPUs or whatever, and it's like, are you sure? And so what you can do is you can start with a high resource limit, footprint what the application actually consumes, like just take a look at it, and then you can shrink it as you need. So you can profile it. Okay, what's continuous integration? All right, this is the one definition that in general the industry agrees on. Because if I said, what is DevOps? It'd be like 10 different answers. If I said, what is, what's another one? Not infrastructure as code, because that's generally agreed upon. DevOps. Oh, microservices. What are microservices? Yeah. All right, so continuous integration. So we talk a lot about CI/CD. So CD we typically understand because that's either deploying, so you get to a deployable package, or it's delivery, right? Deliveries where you get to a package, deployments where you're deploying into production. So then what is CI? CI typically happens when you have different branches, different like features in a code base, and you are merging those against the main deployable branch, right? So it's actually the act of integrating code changes. So you've got a bunch of different branches inside of your Git repository, because that's pretty much what we use now. And you're trying to get the feature, that code that you've added to the repository, to merge against the only deployable branch. Usually it's main. Used to be called master, but it's main now. And so how do you get that changed code into the main? You have to test it. It has to go through like unit tests and all this stuff. So you don't do necessarily like performance tests or like smoke tests per se, but definitely unit tests. And so if it can pass the automated test, then it gets merged into main, and then it can become a deployable artifact at that point in time. So that's continuous integration. Continuous integration is primarily the act of merging changed code into a deployable code branch. Typically, there's also promotion in there where you build the artifact, and you may even go through certain like development, for example. It just depends on what your process is. All right. We are halfway through, and we've got a few minutes, so we're going to keep going. We got about 30 more minutes. All right, so then we just talked about CI, so it'd be totally remiss if we didn't talk about CD, right? What is continuous deployment? Now remember, this is different than continuous delivery. Continuous delivery is typically the packaging of your code into a deployable artifact. And it may have even run through like development and testing environments. So deployment, and I see a couple people put B, right? Continuous deployment is the concept of, we're going to deploy through an environment all the way to production. So typically it's not deploying just straight to production. That's usually bad practice. It's literally deploying, building an artifact, merging the code base, running through all of your tests, building an artifact. That artifact goes into development. It goes in QA. It could go into staging. It could go into UAT. And then it goes into production. And it does all of that automatically. So it automatically promotes, and then that last step where it goes into production, that's the part where it changes from usually continuous delivery to continuous deployment. That's usually where it changes, but people are a little fuzzy with that definition. But the general agreed upon term is continuous deployment is where you're deploying all the way into production. Continuous delivery can be all the way up to building an artifact up to promoting it through, dev and QA and staging or whatnot. Definitely not a manual process for human approval. That's probably continuous delivery. Method for storing deployment configurations. No, oh, that's cool. Sounds a little bit GitOpsy, right? Or app config stuff. Technique for monitoring application performance in production environments. We talked about that earlier. That's APM, application performance monitoring. All right, let's do the next one. GitOps. What is GitOps? This is all over the CMPA exam too, as well. All right, here's your question. What's your favorite GitOps tool in addition to the answer to this question? Yeah. I pretty much say Argo actually is it. Well, what's your favorite tool, Kat? Yeah, it's funny, like, surprise. I agree with that as far as, like, I actually think that almost any build server, CI/CD server, can be used to do GitOps, right? I think the concept of using like a version control system, I mean, I mean, but I don't know that I typically run into clean tools if it's not Argo. I don't you typically do that. I mean, even Jenkins or GitLab or GitHub Actions, all of that uses VCS as a single source of truth. So I'm kind of like, yeah. But the idea is that you're basically keeping all of your configuration information, deployment information inside of a Git repository. That makes sense. Yeah. All right. So if that's the case, that means C is probably the answer, right? You're using Git repositories as a single source of truth. Yeah, Terraform though, just to say this, right? It says that it doesn't Flux, yeah, also GitLab. Terraform though doesn't have a native tool to watch a repository. You kind of have to invoke it, so it uses a little bit more of a push method. Yeah, I have a love-hate relationship with Terraform. Look at this. What is GitOps and why it might be the next big thing for DevOps? Look at the date on this. December 17th, 2020. Huh. All right, so what's the main benefit then of using GitOps for application deployment? Yeah, I know. Hard to imagine. So what's the main benefit of using GitOps for application deployment? Do you no longer need testing? Does it make applications execute faster? Does it reduce container image sizes? Does it provide declarative, version controlled, and auditable deployments? Let's see. Is there anything, by the way, that does eliminate the need for testing applications before production deployment? Because if there is, I'd like to talk about it. Nandini, I saw your answer. Good. Is there one that eliminates the need? Because I need you to tell me right now if this is the case. Because if there's something that eliminates the need for testing, I would love to have it. Oh, Pac-Man. Hey, I wish that was the case. I wish. I so wish. Oh, Cat. Oh, yeah. Is that it? It's you guys are all doubling down on AI. Gotcha. AI is the truth, the light, and the way. I wish it would. I would believe that if AI was consistent. It's definitely not deterministic. It's probabilistic, and I love it to death. But it is like playing the slot machine a little bit. Yeah, that's the first to go. I think writing tests AI can help with. I don't think it eliminates the need for testing applications. Making applications faster, reducing container image size. I think like multi-stage builds and chunking and pruning, right? Probably the best way to do that. So the answer is most likely this one. Declarative version controlled auditable deployments, because GitOps is all around deployments. Besides, it's the only answer that has the word deployment in it. Yeah. My favorite thing with AI is getting it to write code. I have written hundreds, if not 1,000 hours using things like KloudCode and whatnot, because that's what we always have to explore the cutting edge. And I have to constantly get it to write tests and run the tests, right? Write tests and run the test, write tests and run the tests. And I'm having it do feature branching on almost every single thing it does because more often than not, I've had to roll it back. So yeah, anyway, I wish AI was the answer, but it's getting pretty close. Okay, here we go. This is a gimme. We just talked about this. Which tool is commonly used for implementing GitOps and Kubernetes? This should be just like a beach ball, like pow, right? I know exactly what you're talking about, Michael. I mean, come on, etcd, right? They even say what it's for. It's actually for cluster data persistence, so it can't be that. Prometheus we just talked about. Docker. No. Yeah, this one's kind of a gimme. Argo CD. It's pretty much the de facto now, especially I think since what was the primary company behind? Yeah, Docker. Good Rizki or Rizki. Sorry if I'm mispronouncing your name. Uh, wasn't Flux sponsored by Weaveworks? Is Flux still alive? I think Weaveworks, which is a company that really pioneered a few things for everybody, but they went out of business. So I don't know if Flux is still going. I'll have to look that up after this. Okay, what is a deployment strategy? I mean, things can get really difficult. This is very abstract, right? Is it a plan for organizing development teams and assigning project responsibilities? I thought we were going to let developers choose their own work. A method of defining how application updates are rolled out. A system for storing application source code and managing versions. A technique for monitoring application performance and user experience. Okay. All right, so then here's a better question. What is the name of the deployment strategy where you offer a little bit of the new version and you see how things go, and if things go well, you roll everything over to the new version? What is the name of that deployment strategy? So where you offer just a little bit of the new version, and then if it looks good, you just roll the whole thing over. You don't do little bits, right? Yeah, so canary release. That's exactly right. Does anyone know why it's called the canary release? Does anyone know? I mean, I know you could look it up, but like off the top of your head, do you know? That's right, Kat. Canary in the coal mine. So for those of you who don't know, and again, this is horrible. It's like one of those pets versus cattle things. So coal miners used to take canaries into coal mines in cages because birds have far more sensitive lungs. And so if there was a high amount of natural gas, the bird would start freaking out and or die. And that usually meant that the coal miners needed to get out because they didn't have a way of testing for natural gas because, as you're aware, natural gas is odorless. We add scents to natural gas so that we can smell it. So if you're in an enclosed space and this natural gas is pushing out all the oxygen, the bird would start to freak out, and so therefore they usually use canaries, which thank you, canaries, for all of your service over the years. Oh, Jignesh, I'll talk about pets versus cattle in a second. Yeah. So canary deployment is basically you do a little bit, see how it goes, and then you roll like 10%, and if it looks good, then you roll the rest of the 90% over. That's a canary method, right? Blue-green, by the way, is a complete copy of an entire environment. So if you've got 15 servers in your old version, you're going to create 15 servers in your new version. You're going to cut DNS over. That's blue-green, right? Where you're actually duplicating the capacity. I know. I feel sad for the canaries too. And then, of course, there's linear, where you would roll 10%, and if 10% looks good, then you roll another 10%, so you got 20% of your traffic going to the new version. Then you roll another 10% 2 minutes later, and another 10% 2 minutes later, and you keep going at 10%. That is a linear deployment, right? And then, of course, you've got the rolling update where if you've got 15 servers, you just replace one at a time as you go through, right? You've got the complete in-place update where you just replace everything. You don't even care about doing them one at a time. You just roll them out, right? You replace everything at once. So, yeah. If I remember correctly, Kubernetes by default just does one at a time, right? It'll replace one as it goes through. So pets versus cattle. So there's this phrase where you want to manage your servers as if they're cattle, not pets, which means you don't name them, you don't become friends with them. And it's a horrible analogy, just like the canary in the coal mine thing, because I hate to say this. Forgive me for saying this. The pets versus cattle thing is where, like, if you have 15 servers and you need to replace the server, you just kill it and start another one, right? And that's the whole pets versus cattle thing. It's a horrible analogy, and I apologize. I did not come up with it, but it is a thing that is talked about. But pets versus cattle is basically where you will kill your servers because the servers don't matter. You can start them, kill them, add new ones, all that other stuff. So you don't treat them like pets. So if that's new to you, I apologize, but that is. People get sentimental over their server's cat. They'll be like, this is Zeus, this is Diana, right? This is Hades. Like, they'll name their servers and then get attached to them. I know it sounds weird, but it happens. People have done weirder things. So for this, a deployment strategy is basically a method for defining how application updates are rolled out. So whether it's canary, linear, blue-green, as people mentioned, update in place, update one at a time. Yeah, it defines basically how they get rolled out. I know, but people get attached, right? They get a server up there, and they called it, Deku, because they love anime and they like to name it after their favorite anime character. That's what happens, right? For those of you who watch My Hero Academia, also known as Macadamia. All right, so then we just talked about this. Then what's a rolling update in Kubernetes, right? Definitely not a method for creating backups, because we literally just talked about this in the context of deployment. System for monitoring pod performance over time. No, we talked about that. Technique for automatically scaling applications up and down based on demand. Oof. No, but we could talk about scaling, auto-scaling strategies. Yeah, I see that you are all on top of this. It's A, right? Just replaces old pod instances with new ones. Just a rolling update. Pretty much just do it. One, or you can do batch updates sometimes, right? You could do like 2 or 3 at a time, but typically it's one at a time. Yep. And it does say that this is the default update strategy for Kubernetes, right? So just replace one pod at a time. If you run into a problem, you can roll back or relaunch the old version. So I saw the statement about Flux. Thank you for looking that up. Oh, interesting. I was at KubeCon Cloud Native Europe this year in London, Cat, and I did not. Interesting. Yeah, I didn't see any indication that they were going to survive. All right, so what's the purpose of a CI/CD pipeline? Because we've only got a few more minutes, and so we'll probably finish this, and then I'm going to talk a little bit about the exam. What's the purpose of a CI/CD pipeline? I mean, we're not defining continuous integration. We're not defining continuous delivery and continuous deployments. And then the purpose is really just all about building, testing, and deploying, right? We got to merge the feature branches into the main branch. We got to build an artifact that usually goes into our artifact library. All of that has to be tested as it's built, right? And then we're going to test the artifact, and we've tested the code to make sure that there's no static kind of revelations there. Then we run it into development. So we're going to run some security tests there and some performance tests, maybe some other code tests, maybe integration tests. And then we're going to run it through QA, and that's where we might even get like deeper around smoke tests and visualization and regression tests, although that could also happen earlier. And then maybe we run it into like a staging environment, and that looks like production, and so we're going to run a performance test, see how the load test goes. And then we might stop there if it's continuous delivery, right? And say, hey, are you ready for this to be delivered so we can deploy it into production? Or if you're doing continuous deployment, then it goes right out. So it is indeed the automatic building, testing, and deployment of applications. So easy peasy. All right, last two. All right, so I actually just talked about this. What's the difference between continuous delivery and continuous deployment? All right, let's hear it. I know you've got this. I know you feel it in your bones. You're like, I know the answer to this. I got this. All right. So we know they're not identical because we've already talked about this, right? This is for testing and production. Ooh, that sounds pretty good. Continuous delivery uses Git workflows. Deployment uses other tools. No, that's not true. Continuous delivery requires manual approval. Continuous deployment is fully automated. Whoa. Whoa. Huh. This gets a little confusing, doesn't it? Right? Even I'm like, huh. Isn't continuous delivery for testing environments? And it does. Does this require manual approval? This is fully automated, but isn't this also automated? Oof. Man. Gets a little confusing, doesn't it? Well, in this particular case, right? Oddly enough, continuous delivery is for testing environments. I would argue that this could actually be true, so I might have to revamp this question, right? Because delivery does actually take place predominantly in testing environments, and deployment is actually adding the production environment. But this is also true. Continuous delivery, if you want to go to production, does require manual approval, but if you are doing production and you're using continuous deployment, it's fully automated. So I would argue actually that B and D are actually right. So, I'm gonna have to fix my question. By the way, there's usually 4 reasons why you get a question wrong. Right? 1, you don't know the answer. I know that you're like, that's obvious, Michael. 2, what you think is the right answer is wrong because your information is wrong, right? So, like, 1, either you don't know the answer. 2, what you think you know in your mind is incorrect. Like, for example, the information is outdated or a feature flag has changed. So the information you have in your head is incorrect, right? So this one is you don't know. This one is that the information you have is incorrect. The third is typically because you didn't read the question. Like, typically you missed some keyword like security or reliability or cost effective, like you missed some aspect of the question. And the fourth, and this is the case here, the question is bad. The question or the answers are bad, right? So in this case, yeah. I did write these questions myself, Kat. I was feeling so proud of myself, and then we got to the last one. And it's a bad question. So this is reason number 4. This is a bad question, right? Or at least bad answers. The question's good. So anyway, I'll have to fix that. All right, last one. Okay, we just talked about this. We just talked about canary deployments. Let's celebrate our poor canaries who have given so much so that we can burn coal. That sounds like a whole discussion in and of itself. All right, so how does that work? Is it all of it at the same time? Is it deployment only during a certain window? Is it deployment requiring manual testing of every feature? Well, I've worked in a lot of places like that, yeah. Yeah. I mean, people who crawl into a hole to like mine stuff, I feel like maybe they deserve some protection, but I do feel bad for the canaries. Anyway. Yeah, so the answer here is, looks like you all have it, is that basically we're going to release updates to a small subset before rollout. I will point out that I don't think that the first miners were made to take canaries. I think they figured it out. I want to say that they got it from the Egyptians, actually, but that could be a horribly made up statement by me. I think it was the Egyptians, though. They figured out from the Egyptians that birds apparently were more sensitive to gas. Also, can you imagine that the light sources they took down there were flame-based? So can you imagine what would happen if there was a certain concentration of natural gas? Yeah. I mean, but it also saved a lot of lives. So again, the canaries helped us. They helped us. Anyway, all right. So this is the deal, right? Canary releases is that it's a small subset, usually like 5-10%, and then if everything looks good, you just roll everything over to the new version. Yeah. I know. Okay, so let's talk about this before we close, because we've got about 10 minutes, and I just want to mention this. So you've probably gotten actually a feel for the KCNA exam at this point in time, right? So I'd be completely remiss if I didn't just talk about this one more time. And I'll answer that in a second, the question about future sessions. So one, this is $250 USD exam, right? Obviously you can get a bundle if you want to. But just remember, these are all the domains. So all the questions that we've been answering, particularly around CI/CD, GitOps, application delivery fundamentals, notice that Prometheus is just bam in there. It's its own thing. A little bit around cost management, telemetry, and observability, but like we've covered all of this in our reviews. So just a reminder that if you're interested in taking this, if you've taken the CKA, honestly, you're probably just going to pass this whole, like you just pass it easily. If you haven't, this is a great place to start. So just a reminder that the KCNA is a great place to start. My recommendation, by the way, is you take KCNA if you haven't taken CKA, then take CKA, then take CCAD, then take the KCSA. I know, there's another one for security, and then take the CSA. So if you're going to go for the Koopstronaut or the golden Koopstronaut, notice there's the blue Koopstronaut and then there's the golden Koopstronaut. So that's where you're headed. So yeah. So Cat, CKA before CCAD? Yes, CKA before CCAD. Did I say CS? I meant CKS, yes. Blue for money and gold for even more money. Yeah, that's true. So if you're not familiar, obviously the Koopstronaut program is where you get all 5 of the kind of certifications. So my recommendation again is that you take the KCNA, take CKA and CCAD, then take the KCSA, then take CKS. Just makes it easy, right? So the K first, then CKA, CCAD, then the other K for security, and then take security. So KCNA, CKA, CCAD, KCSA, and then CKS. So you're basically putting the security ones together. Koopstronaut is a big deal. If you ever go to the conference, by the way, they will definitely, they are very kind of, woo, congratulations. It's kind of cool. This one, if you decide to go for Golden Koopstronaut, I just want to tell you, KodeKloud laid out as KCNA, CCAD, and CKA. Really? Well, that's weird. Yeah. That would be interesting. CCAD first. I mean, I guess you could go for CCAD first. I mean, I don't necessarily consider CCAD easier than CKA per se, although it is just about application deployment and developer pieces, yeah. But I guess you could do it that way. That's not my recommendation. I just go after CCAD. Should we learn Linux before learning KCNA? So I actually recommend that you do KCNA before you do Linux because KCNA is relatively conceptual and there's no Linux commands in there. Although, I'm probably the wrong person to ask because I've been working with Linux since 1998. So I would say, though, somewhere in there, Linux and KCNA should be first, ideally. Before I answer the other questions, is that notice it says CKA, CCAD, CKS, KCNA, KCS, so all of the Koopstronaut stuff. Then there's Prometheus. Then there's Istio. I don't even know what this is. This is probably Cilium. Let's go take a look. Yeah, that's Cilium. So that's Cilium. This is that Argo? Yep, that's Argo. Then there's GitOps. So there's Argo and then GitOps. Then there's Backstage. Then there's OpenTelemetry. And I don't even know what KCA is. What is KCA? What is KCA? Oh, Kyverno, of course. I should remember that. So by the way, they're going to add more to this. Just so you're aware, if you are going for this, then you probably want to go for this. And then, of course, there's the LFCS. So they just added, by the way, the LFCS piece in there. It wasn't in there before. This is all for the golden, right? So anyway, that may be wildly out of reach for most of us, honestly. But anyway, as far as the KCNA exam goes, these are the domains. I'm going to share the PDF here in just a second. I would say, again, if you're studying for the CKA or CCAD, I think KCNA honestly ought to be your first reach. All right, so questions. Questions. I'm glad the questions were helpful. Good. Someone asked about another session. So there's let's see. There's a poll. Let me share my Discord here for a second. There's a poll out there under general chat that says, hey, what would you like to study? So if you want to study something else, you can put this in here and just say, hey, I want to see, KCNA again. If you want to study for like CKA with me, we'll probably pop open a couple of labs and actually do like CKA study. That's another option, which it looks like that's where most people are headed. And so we will pick this up again in July, because oddly enough, I'm going to be out of town in London for a little bit, so you all will not see me. But we're going to do this on the monthly. So the next time that we will pick this up will probably be the second week in July. So whatever you vote for here in this study is exactly what we're going to cover. So if you want to see CKA or you want to see some other information, you want to do another exam, that's exactly what we'll do. So just put your vote there. Let's see. Do you recommend starting a home lab for KCNA? So I am a fan of a home lab just overall. And if you're going to stop at KCNA, a home lab is overkill. If you're going to go for CCAD or CKA or any of the other stuff, a home lab, or at least the ability to start a cloud lab, is absolutely essential. So I don't think you could go wrong with that. I actually am in the process of converting my little like mini boxes, because someone gifted me a bunch of little mini, they're like $100 little mini Nooks, like mini PCs. I was so grateful. I mean, obviously, you know, you do cloud if you wanted to. But I'm actually converting them over to Talos Linux, because I was running Proxmox on them to do virtual machines. And I decided to go all in to Kubernetes and just run KubeVirt instead, which does virtual machines. So I'm actually running Talos Linux, which I have to say, Talos Linux, Talos is actually pretty cool. It's completely immutable, and he uses a istio-ctl, like kubectl style binary to manage the system, so it's really cool. So definitely, I don't think you need to learn Linux before KCNA. Any experiences from the recent new exam you gave? So most of the questions that you're seeing are from when I took the exam in, I believe it was February. Actually, let's go take a look. When did I take this exam? Because I have a new login. Let's see. Where did I take it? Let's go take a look at my exam history. Was it February? Yeah. So it was February that I took the KCNA. Yeah. So, Kat, what I usually do is the minute I get done with taking the exam, I just turn on a voice recorder and spit out all the stuff that I remember. I did that for the CMPA, which I actually just took 2 days ago. And then I just spit out everything that they ask questions about. Like, for example, I'll give you a serious example. The CMPA exam actually asked me about Helm flags. It actually asked whether it was Helm upgrade -- replace or Helm upgrade -- install. And I was like, oh my God. And I knew the answer, but I was like, why? Why are you asking for flags on an associate's level exam? And it turned out, by the way, that it was a test question. Like, it wasn't a real question. So one thing they don't tell you, by the way, and I didn't see this with the KCNA, but they might be doing it, is that the CMPA was supposed to be 65 questions, and it was 85 because there are fake questions in there. So anyway, yeah, so there are some fake questions where they're testing questions. So, yeah. So to answer the questions is that we're going to pick it up again in probably July 11th or 12th, whatever that Thursday is. Vote on what you want to see. I will post the 4th recording and the PDF file into the KCNA channel. And if you have any questions, just tag me. I'll be glad to answer them. But you're going to have the entire PDF to study, so you just let me know. Let's see. Did I miss any questions? Oh, where do we vote? So I don't know if you could see, but it's under, if you go under the general chat, there's a little study session like poll that's happening there. It started as a new thread. What should the new study with Michael sessions cover, right? So put your suggestions here. Hopefully that's helpful. Yeah. All right, it's 8:30, so I want to be mindful of the hour. I think I answered everybody's questions. Yep, Sailor.sh is awesome. I think there's everything else. Experiences. Netify. Oh, that's good. Netify.app. Awesome. I would do KCSA before CKS because uh, it it gives you a broader overview. CKS gets a little bit deeper into the space. The KCS is a lot more shallow. So it can't be cool to test yourself. Why not? It could be cool to test yourself as long as you don't cheat. I think it's cool to test yourself. Yeah. All right, y'all. We're 1 minute past the middle of the hour. It's good to see y'all. Thank you for participating. Hopefully, we'll see you next time. Tag me on Discord if you need something. Otherwise, I will be in London for 10 days, and I will catch you all after the 4th of July. So we'll see you then. All right. Take care, everybody. Da, 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 da.